Hello and welcome to this video. My name is David Dawn, and in this video we're going to be talking all about how to understand encapsulation. And in the video we're going to go over a few things. Now, up until now, we're now on the 75th video in my Learn Swift with David playlist. And in this video and from now on, we're going to take off the learning wheels, right? We're going to start take off the L plates, and we're going to start actually using Swift properly now. So as far as I'm concerned, if you've got this far, if you've watched every single video, then you are competent enough to understand all of the things on this one list, and we can start actually making things and creating things that you are going to see throughout your programming lifetime, and you're going to be using all the time. And so let's now just jump straight into this. Let's just talk about the things that we are going to use in this one video. We're going to use function types. We're going to introduce you to escaping, and you've seen closures already. You've seen structs already. You've seen collections all over the place, although I haven't taught you about them. Dictionaries are not that much different to collections, so you'll understand it pretty quickly. Classes I haven't shown you at all, but they are pretty much exactly the same as structs, just with a few additional other benefits, which we're going to use in this. I'm not going to talk about it, we're just going to use it. Generics you've seen, you've been introduced to already, and by the end of this video you'll know about them even more. And type aliases I've shown you already too, because we've dealt with associated types and type aliases, etc, etc. So with that said, let's jump straight in with the first example. We're going to do two examples today. So the first one is going to be an action, and we're going to use a struct for this. And this action's, what's going to happen is it's going to take one value of one type, and then it's going to save that one value, and then it's going to pass that value to a function type, and it's going to return a different value. So it's going to kind of like map them on. All right. So the idea is that one part of the code can execute. They can provide it with a value, right? Provide it with a value, and then it will receive back another value. So it's like kind of like mapping the value. So let's just say here it's going to receive a value of u, or sorry, it's going to receive a value of t, and it's going to return a value of u. All right. So this is what we want our execute function to do. So now that we have generics, we need to tell the constructor here what it is. That it actually is generic. So now we've passed out that problem, and now we need to actually return this one u. Well, we don't have this yet, so we're going to need to define what this callback is and where this callback is going to come from. And the callback is going to come from the person or the area of code that is going to instantiate this action. So we're just going to say private because we don't want anyone accessing this, and we're going to say this is then the callback. The callback, and inside of this callback, as already said, it's going to take a t and it's going to return a u. Very, very simple. And let's just do a print here, execute action with value here, and then we're just going to return the callback, and we'll pass it the value. Okay, very, very simple. And you might think that we're done here, but obviously we don't know how to instantiate this action because this one property is private, and the Xcode will not be able to do it because yeah. Anyway, so we need to instantiate this callback. Now this is where the escaping comes into it. So I'm going to skip over this as quick as possible, but basically this escaping is saying, hey, this function type here, this is not going to be executed with inside of this one code block. All right. So it's saying by the time this one, this curly braces here, this needs to be saved, and you need to use it later. So you need to escape it and just use it later. All right, save it somewhere in memory and don't discard it. And so that's basically what it's saying. You probably could use about another 40 sentences to describe it even further, even better. But in order for us to use it down here, with it being saved inside of this one struct, we need to use the escaping attributes here. All right, and it needs to come before it. Okay, and you can't put it with inside of the variable here, the struct member. You put it inside of the constructor like this. Okay, and if you would then do it in the execute function, you would put it there too. So there we go. This is what is going to happen. So now we're just going to say action is equal to action, and we're going to tell our generics what we're going to do, and it's actually the other way around we want to do it. We want to do int and then we want to do string, and then we can use a trailing closure on this, and in here we're going to say received value, and we're just going to do here and say value first of all, just to give a little bit of context of what's going on. And then we're going to return, then we're going to return a string of that one value, all right, of that one integer. And everything compiles perfectly fine, but nothing is actually going to happen yet. So when we come and execute it, we come and execute it with 10, and you can see that we get execute action 10, received value 10, and then when we actually put it inside of here and we run it, you can see that we get 10 as a string put out. So this is now introduced you to structs, which you've seen already, generics, which you've seen already, closures and function types, which you've seen already, and you've seen all this already, action functions and stuff, but you hadn't seen escaping. And this is the whole point of encapsulating. We are encapsulating this business logic of this one, basically of this business logic here inside of this callback. We are encapsulating it with inside of this action, so we can pass this action variable further on and they can just execute it when required. The people, the person, the place, the area that says, hey, action, I've got some data that you might want here, they don't care about the implementation. That's why we're encapsulating the implementation. And if we wanted to generate a getter function that says, hey, give me the callback, we could do as well. And this is the whole point of encapsulation. You might not want the outer parts of the code or outer parts of the struct see all of the small details here. You might want to only give it a little bit of data, not the whole data. So this is the whole part of encapsulation, is that you are taking like member properties and functions and you are placing them all within inside of a struct or a class, and you are then encapsulating all of that data to pass it on to someone else. It's not really much more than that. So it's a way of bundling business logic together and passing it on further, all right? And also keeping some elements of it private or and so on. So there we go. This is the first example done now. So let's just comment that out so it doesn't disrupt us down here. And let's go on to the next example. All right, so let's go back to what we've done. We've done function types, closures, escaping, structs, collections, we're not done yet, dictionaries, we're not done yet, classes, we need to get onto. So the next one is going to be the publisher consumer pattern. All right, so we're going to make a class. I'm not going to talk about classes, we're just going to use them. And in this class, we are going to have a type T. All right, so this is going to be someone wants to subscribe to a stream of these T's being sent, and yeah, then someone can emit these. Send basically is on the publisher. So we need two functions first of all, and we're going to half implement both of them when I can write properly. We've got a subscribe function, and then we've got an emit function. You could call it the send function as well, but we've got a subscribe and an emit. The subscribe function is the thing that is going to be the consumers of the T's, and then the emit are then going to be the publishers of the T's. Okay, so subscribe, this is going to be a callback, but let's create the emit first because this is probably the easiest one. So we're going to say emit T, and this is basically it. That's all it's done. It's going to say, hey, I've got a value and this is of type T. And then the next thing we've got to do is we want to have multiple subscribers be able to subscribe to this at any one point. Okay, and so this is going to be a callback, or you could name it, it's a better name, right? It's a consumer, and this is going to take a T, and it's going to be void, all right? Because we need to pass it this one value. Okay, this value is going to be gone into here. This is this T here. So we've got this consumer here right now. Now we want to be able to save every single consumer, but we want to also allow the subscriber to remove it when they want to. So we need some way of saying, hey, once you want to finish it, then we're going to finish it as well with a cancelable, and we're going to call it a cancelable. And we're going to say type alias here, and we're going to call it a cancelable. And this is going to be what's called a encapsulable. And we're going to do it here. All right, so this means that we've got to return a void function type. But we need some way of referencing this one function type because we've got to save it to be able to remove it later. So first of all, we need some place to save this, okay? And we're going to use a dictionary for this. And this is going to be called the consumers. And this is going to be a dictionary, a key value pair, all right? And it's going to take a string as the key, and the value is going to be a cancelable, okay? And we don't need sorry, it's going to be a consumer. We need to copy in this, all right, because we need this as well. And this is going to be a consumer, and this is going to be of type T here. So this is going to be of consumers, and we need to say T, and we're going to instantiate it with an empty dictionary. This is a syntax to create an empty dictionary. And this is a syntax to define what type the key is and what type the value is, and so on, all right? So these are not, yeah, this is a type of collection. An array is a collection, and a dictionary is of type collection. So every single time someone calls this subscribe, we want to add this one's consumer to the consumers. But we need a way of referencing it first of all in here and also later inside of here. So we're going to enclose, we're going to add an ID, this string, to the scope of this one callback that can be called later so we can reference it. So we need to create this UUID here, this universal identifier. And we're just going to use UUID, nice and simple, and go straight to the UUID string. And now we've got this here, we can encapsulate this UUID inside of here, right? But first thing we want to do is we want to add the consumer to the consumers, okay? And all we do here is we just use a dictionary and we say, hey, add a key of this UUID and set the value of this one consumer, okay? Now, when they call this one cancelable to remove it, and obviously we need to add then the escape in here as well, because you can see that the second we start saving this is that when the compiler will say, hey, you've got to add escape into it. And so when this cancelable gets called, this is where we need to remove this consumer from this one dictionary, okay? And so in here we're going to have to reference self, and we're going to have to say consumers, and we're going to say remove at key. Well, we already have the key, which is fine. Now we're going to just say this here, and I'm just going to do this anyway, and I'm not going to explain it, but I'm just going to show you that it's worthwhile doing this, okay? And I'm not going to explain, I'm just going to leave it there for a future video. So now when we do subscribe, we've got UUID, we add it to the consumers up here, that's perfectly fine. And then when this cancelable gets called, we're going to say, hey, remove this one value. So when the emit gets called, we're going to say consumers for each, and inside of here there's going to be a value inside of this. Oh, sorry, we want consumers for each value, so we don't care about the keys. So we're going to say then that this is then consumer here, and inside of the consumer we are going to then just say value, all right? And that's pretty much it. So we let's rather than do any cancellations here, let's create a publisher first of all. Publisher is equal to publisher, and it's going to be of type string that we pass it. And let's just say publisher first of all, and emit, and we'll just say hello world. And when you see this, you'll see that nothing are not allowed at the top level. We're going to have to move this to the main file to be able to execute it. So let's just come over to the main file and come down here, and now we've got our publisher, and we can say publisher.emit, and when we run this, you can see here nothing actually gets outputted because with inside of the publisher we consumed it, right? But let's just take we consumed it, but we haven't actually got any consumers, sorry, we emitted it, but we haven't actually got any consumers as of yet, so nothing actually happened. So let's now come to the publisher, and we're going to need to have a we're going to call it a dispose function, and we're going to say publisher and then subscribe, and we can do a trailing closure on here, and we can then say the values in here, and then we can say in here then we're going to say consumed value. All right, and when we do this once again, we run it once again, you can see here consumed hello world. All right, now when we come down to the bottom, if we create a second, if we create now a second, and we'll say consumed 2, this is the second consumer. All right, and when we do emit here, and then we do dispose of the first one, and now we admit the second one, and say hello world 2, you'll see how many times. Oh yeah, I spelled dispose wrong. There we go. And you'll see how many times this gets called now. Okay, so we've got consumed hello world, which is called in here for the first consumer, and then we get consumed 2 hello world here, which is then the second one, and then we admitted it, we disposed of the first one, and now we admitted the second hello world, and we only got consumed 2 hello world 2. So as you can see here, that when we called this dispose, the business logic that was encapsulated within inside of this subscribe here, it removed the UUID from, it removed this consumer from this dictionary, so it wouldn't be called next time. All right, and so this is a very, very important process here to understand, especially the publisher consumer pattern. All right, and how to be able to write these yourself, because when you can start writing them yourself, you will get a extremely higher understanding of reactive programming. And when you start using Swift UI or UI kits with the likes of RX Swift and so on, or you use Combine, or you do a lot more, you really need to understand reactive programming. And this is an introduction really to reactive programming. And if you start using UI kits rather than using Swift UI, then you are going to see a lot of closures. Now, there are other async and await, but that was added a little bit later. So you're going to have to learn a little bit of legacy code as well, how it was done beforehand, and then how it was done after async and await come, because if you're going to be a Swift developer, you have to understand how to fix old legacy code and convert it to new code. And sometimes you can't convert it straight away. So it's important to understand these different patterns and how they work. All right. With that said, I hope I've shown you now encapsulation. All right. Remember, we are encapsulating this callback. We're encapsulating this business logic, and inside of this publisher, we are encapsulating the consumers. From outside, no one knows, or the users of this publisher down here, they don't know about the business logic within inside of the publisher. All they know is that they get a dispose function that they can call when they're finished with it, right? And then they get the values as they are added. Okay. So now if we just move this hello world here, and let's just put dots after it, and we run this once again, you just see you get consume 2 hello world 2, right? Because this hello world ... got omitted. Then the subscriber subscribed to the publisher, and then the second subscriber subscribed to it. We disposed of this one here, and then we admitted this. So this one subscriber never actually saw any data, because this we are not saving these values. Okay, now there are other ones where they actually save the values, and then you receive all of the previous values as well, but this is only ever emitting the current value. Okay, and it's not saving it either, so it forgets it immediately. So we are not encapsulating this history of data that's already been passed to it. Okay, with that said, I hope that you've learned something in this one video. This is a really important pattern to understand, and it's really important to understand the generics with this, and it's important to understand how to save data. Now, I just want you to highlight here, if you're going to take anything away from this, you're going to take away classes. They are basically the same as functions, but as you can see, we didn't need mutating here because they're classes. They have an extra superpower. They have a few more extra superpowers, right, than what structs do. Structs are value types. They're supposed to be as immutable as possible, whereas classes, they are like, I'm not immutable at all. Change me whenever you want, however you want. They don't care, all right? And this is why you've got to be a little bit more cautious about using classes, and when you understand the abilities of classes, but there are also some things that you've got to be careful about, and these are called memory leaks. And I just wanted to highlight to you here how you can deal with possible memory leaks, okay? Or you can stop possible memory leaks in the future. But that there in itself is a very, very deep, dark topic to get into, because you've got to fully understand how this all works, okay? With that said, thank you very much for watching. Please don't forget to like, subscribe, share, and do all of the other social media things that are out there to do to this one video. I really appreciate you watching my videos. I hope that you learn stuff on it. That's my only goal here, is that you learn things and you've got a reference to videos. And I want you to feel like you're sat down next to me looking at this, and that you can ask me questions, but I already kind of try to think of what your questions are prior to me speaking, so I try and answer these questions for you already, and I try and add content afterwards or before to make sure you've already learnt it. With that said, if you do have any feedback or any concerns or questions or anything like that, then as always, let's start a conversation in the comment section down below. I really appreciate all of the support that you guys are giving me, you people are giving me, you humans are giving me. Thank you very much. I really appreciate it. With that said, it's Friday the 12th of July, it's 9:20 in the morning. It's the weekend. Have a nice weekend, and look forward to the video tomorrow. Ciao, ciao, and goodbye.